Hello class, this is a video tutorial on trigonometry and the unit circle. So we understand trigonometry in terms of the basic ratios in the context of right angle triangles. So we know, well, SOHCAHTOA, and when we apply it to, let's say, this particular triangle like this, we get these ratios. And from here we can solve for an angle and we can solve for a missing side. And obviously we can apply these to bearings and angles of elevations and etc. However, we may be able to recite these ratios, apply them to problems and generate solutions. But what are sine, cos, and tan exactly? As a point of comparison, we understand at the most basic level what addition is, as well as what the symbols mean and what it means to use them in a question. So for example, if I had 1 plus 1, what it actually means is we have one object plus another object equaling 2 of that object. But what about trigonometric ratios? What does that mean? By exploring these ideas, we will obtain a deeper understanding of our trigonometry, but also extend our knowledge to what would seem at this stage of your mathematics course impossible. That being negative angles, trigonometry with non-right angle triangles, and trigonometric equations. To build on this foundation, we must understand first the unit circle. So the unit circle is a circle centered at the origin. Okay, there's there. And we need to draw the circle. So it would be like something like this. Okay. It has a radius of 1. So if I draw a length from the middle to anywhere around the edge, it has a length of 1. And for the angles that we need to do trigonometry, there are 2 more sides we need to understand. First is the initial side. The initial side is always going to be from the middle out to the positive x-axis. That is our initial side. The terminal side is we take the same arm, but we're going to rotate until we generate the angle that we want. So for example, if I wanted, let's say 45 degrees, I'd stop about here. And we label this our reference angle. And the triangle that we generate is the intersection between the circle and the terminal side. So this one here. And we draw it down to the x-axis. That there is our right angle triangle. We, just as a point of comparison, we could have rotated this, we could have rotated this terminal side up here for a larger angle and drawn our perpendicular height down like so. Or we could have made it smaller, down like this, which means our perpendicular height will be much smaller, like so. And our reference angle is still always going to be in between the initial and terminal side. Now, just to make things a little clearer, I've made a neater version here. And also, we're going to zoom in just for now on quadrant 1. In case you've forgotten, we have 4 quadrants in the number plane. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. For now, we will only be focusing on quadrant 1. So that is the unit circle. And now let's start applying some trigonometry to these ratios, to this triangle. We still apply sine, cos, and tan, SOHCAHTOA, but now we're going to take into consideration the unit circle and the Cartesian plane. The question I have for you now is, what is the length of the hypotenuse? And what are the lengths of the opposite side and adjacent side? Well, let's first consider the hypotenuse. The hypotenuse is actually from the middle to the edge of the circle. And like I showed you in the previous example, we could have actually drawn it here, or we could have drawn it down here. But the main point I'm hoping you're seeing is that this is actually the radius. So the hypotenuse radius is always going to be 1. Now what about the opposite and adjacent side? I want you just to follow along. This point here, which could have stopped here, we could have drawn the triangle like this, or we could have drawn the triangle like this, or we could have drawn the triangle like this. But the main point is that anywhere that it stops, it corresponds to an x and y coordinate. You see that this length here, the adjacent side from theta, corresponds to the length of x. This is actually a length of x. Likewise, this length of the opposite is actually the same value as this y value here, this y coordinate. This is a y. From this, we can conclude that if we apply trigonometry to this, we get sine of theta is equal to y, the opposite, over the hypotenuse of 1. But y over 1 is just sine theta equals y. Likewise, if we apply this to cosine, cos of theta is x over 1. Well, x over 1 is just x, so cos of theta is just x. And lastly, if we do tan of theta, that's actually y over x, so opposite over adjacent. So it's going to be y over x. And I hope you've seen a connection here. Y is actually sine. So we can, and actually x is also cos. So tan of theta is equal to sine theta over cosine theta. Okay, I hope you're beginning to see where this is going to apply. I'll be doing a few examples in the next video, but for now I hope you understand that sine of theta corresponds to the y value of when we draw a unit circle of the angle that we are drawing. And that cos theta means we're going to draw a triangle inside the unit circle of angle theta and measure the x value at that point. I hope that gave you a little bit of insight. I'll be doing a few examples in the next video. Hope to see you then.